All right, Shay. Um, this is a video how to simplify algebraic fractions under the operation of addition. As you can see, these are two separate algebraic fractions, and they are under operation due to addition, as you can see here. So these two fractions has two separate denominators, right? So this denominator is 2, this denominator is 5. These cannot operate at the moment because they have two different denominators. So, in order to be able to simplify this operation, we have to simplify it. In order to simplify it, we have to find a denominator. In other words, you have to find a lowest common factor that we can put for to solve and simplify this entire fraction. So let's get into it. So first, we're going to find the lowest common factor. In other words, just multiply 5 by 2, we get 10. Right, so let's do that. So we're gonna put our vinculum down. This is our vinculum. 5 2s are 10. Right, so the reason why I did that is because 2 could go into 10 5 times, 5 could go into 10 twice, and as you can see, these two kind of add up to make that, right? Great. 2 into 10 is 5. Now with this, that means that we have to multiply 5 by this entire fraction, right, in order to make it into this, in order to simplify it. So 2 into 10 is 5. So this entire numerator on top here, x plus 1, has to be multiplied by 5. Right? So 2 into 10 is 5, but not here. Right? And we know that when you have a bracket, right? When we have a bracket, everything inside the bracket multiplied by the number out of it, right? Right, so we're gonna have 5 times x plus 1, because as I said, this entire numerator is multiplied by 5, right? Right, and the operation here stays the same. So this will be plus, because it stays the same. Right, now how much times can 5 go into 10? 5 2s are 10, right? So this entire numerator has to be multiplied by 2, right? Because 5 could go into 10 twice, right? So it will be 2, and to show that this entire numerator has to be multiplied by 2, in brackets we put 5 minus x. Right, so far we established our lowest common factor in order to make this entire operation into a one fraction. Right, now we have to in order to simplify this further, we have to expand the brackets. So this will give us 5 multiplied by x, then 5 multiplied by 1. Then that will give us, bring down the vinculum over 10. Right? So this will be 5x plus 5, because 5 times x will give us 5x. 5 times 1 will give us 5. Bring down the operation, right? Same operation from the beginning stays, right? So now we go over here now. So we have 2 by 5 and 2 by minus x, right? So continues. So be expanding this bracket here, right? So this will be 2 5s are 10, right? And 2 multiplied by positive 2 multiplied by minus x will give us minus 2x, because we know in multiplication a positive multiplied by a negative will always give us a negative. So we get 10, because we got 2 times 5 will give us 10. Now we have positive 2 times minus x will give us minus 2x. Right? So what we did just now, we just expanded the brackets. We expanded these brackets here. And this is what we get. Now we want to continue our operation, our algebraic operation. So we have a 5x. A 5x cannot add to a 5 because it does not have an x, so they are not like terms. This is to the 5x to the power of 1. As you can see, 5x to the power of 1. Right, so that cannot add to something that does not have an x. This is 10, so these terms are like. Like terms can only be operated together. This here, however, is minus 2x. So this has an x to the power of 1. This has an x to the power of 1. So these two terms can't operate together. And these two terms can operate together. So in the next row, I'm going to show you how we operate that. We're going to have, we bring down our vinculator, our vinculum. And that will give us now, going to bring only 10, our LCF, lowest common factor. So we're going to have 5x. We want to simplify this, so I'm going to show you 5x. These are similar terms. So you have 5x minus 2x. We're just simplifying it because this is 5x here, this is 2x here. Bringing it together so you can see it easier. This here stays the same. Plus 5 plus 10. Notice how these terms stay alike. Everything has not changed. I will just alter it for you to see it clearly. So now 5x minus 2x. We just change these values because the x stays the same. So 5 minus 2 will give us 3. Bring down our vinculum. Put 10. So 5 minus 2. 5x minus 3x. You just subtracting the whole numbers. So that'll be, well, the x coordinates. So this is 5 minus 2. Give us 3. In other words, 3x. Plus, as you can see here, plus 5, positive 5 plus positive 10, or in other words 5 plus 10 will give us 15. Now I know you may be tempted at this point to factor off these, but the reason you can't do that is because this 15 is in an operation with the 3x, right? So it cannot be done that way. What you will have to do, you will have to factor out this operation on top by using factorization, in other words brackets. So what we can do here, this operation can be divided by 3, because 3 can go into 15, right? Because 3 5s will give us 15. And 3 is already multiplied by x, so if you multiply 3 by x, you're going to get 3x regardless. So let me show you how that works. So the last form of everything here will be like this. So you'll have, bring down the vinculum, you'll have your 10. Now we put now a factor brackets, right? So as we can see here, 3, alright, multiplied by x will always give us 3x, right? So, and 3 multiplied by 5 will give us 15, right? So we could put x, we could put 3, right? 3 times x will give us 3x. 3 multiplied by x will give us 3x. Right? 3 multiplied by 5 will give us 15. Right? So that's how it works. Because 3 times x will give us 3x. 3 multiplied by 5 will give us 15. And this is how we factor to make the fraction as simplified as possible. Remember, this fraction, this means to multiply. This bracket means multiply, right? So if you multiply 3 by x, you get 3x. If you multiply 3 by 5, you get 15. And this is as far as it can go, because these two cannot divide without dividing this as well. And nothing, these 10 cannot, 3 and 10 can't divide, x and 10 cannot divide equally. So it's as far as this goes.